Hello everyone, welcome to this short chapter on sampling distribution. First, we are going to go over the definition of sampling distribution. It's the probability distribution of sample statistic that is formed when random sample of size n are repeatedly taken from a population. So the meaning is this one: you have a population. Say, for example, this represents your population. So from here, you are taking the sample of size n, and you are taking all possible samples from here. So you are taking all possible samples of size n, and you are calculating the statistic. That is, you may be calculating the mean. Say, for example, you are calculating the mean of the first, mean of the second, mean of the third, mean of the fourth, and you're calculating mean of all these. Or maybe your statistic could be you're calculating the proportion of each of them. And if you look at the distribution of those means or proportion, that is the sampling distribution of mean or sampling distribution of proportion. So basically, we are looking at two different types of sampling distribution here. The first one is sampling distribution of mean. That is, when you take the samples over here, if your statistic is a mean, then we say that the distribution of the mean is the sampling distribution of the mean. But if you are calculating the proportion of each of these samples from the population, in that case, the distribution of your statistic is called the sampling distribution of proportion. So in this video, we are going to explore these two sampling distributions: sampling distribution of sample means and sampling distribution of sample proportions. Okay, first, sampling distribution of sample means. Sampling distribution of sample means is the distribution using mean computed from all possible random samples of a specific size taken from a population. One more time. Suppose you have a population here. So from here, you are taking all possible random samples. You are taking the first random sample of size n, second random sample of size n, third random sample of size n, fourth random sample of size n, and so on. Suppose for the first one, your mean is x bar 1. For the second, it is suppose x bar 2. Third, x bar 3, and so on. If you are looking at the distribution of these sample means, x1 bar, x2 bar, x3 bar, and so on, then the distribution is called the sampling distribution of mean. So there are some key things that you have to know about the sampling distribution of mean. The first one is the mean of sample means. So here you have the means like x1 bar, x2 bar, x3 bar, maybe up to some xn bar. So if you want to find the mean of all these, then we can write that as the mean of mean. That will be equal to the mean of the population. That is equal to the mean of this population that you have taken. Next property is the standard deviation of the sample mean will be smaller. The standard deviation of sample mean will be smaller than the standard deviation of the population, because this is how you find the standard deviation of this distribution. Standard deviation for this distribution is sigma x bar. It is equal to population mean divided by the square root of n. Because you are dividing the standard deviation of the population by the square root of the sample size, your standard deviation for the sample distribution will be smaller than the population standard deviation. So based on this, I have listed the formulas here. So if you want to find the mean of means, it is equal to population mean. Standard deviation of sample mean is the standard deviation of population divided by the square root of the sample size. Sometimes the standard deviation of sample mean, it is also called the standard error of mean, and we write that as SE, standard error. Okay, let's take an example. So here is our first example. Children between the ages 3 and 7 watch an average 27 hours of television per week. So what we know is the population mean is 27 hours. Assume that the variable is normally distributed and the standard deviation is 4. So population is standard deviation is 4 hours. If 25 children between the age of 3 and 7 are randomly selected, now we are taking a sample of size n equal to 25. What we have to do is we have to find the probability that the mean of the number of hours, we have to find the probability that the mean of the number of hours they watch television will be greater than 25 hours. So one thing to note here, they have given the population mean and population standard deviation, and the time they watch the television is normally distributed. But what we are doing here is we are taking a sample of size 25. So we are looking at this sample. So if you want to find the mean of the sampling distribution, so mean of your sampling distribution is equal to population mean, which is mu, equal to 27 hours. And the standard deviation of the sampling distribution is the population is standard deviation divided by the square root of the sample size. So population is standard deviation is 4 divided by square root of 25, which is equal to 4 over 5 or 0.8. So if along the x-axis we have the sample means for sampling distribution, the mean of all these, mean of the sample means is 27, which is here. Standard deviation, we just calculated 0.8. Now what we have to do is we have to find the probability. This is what we are looking for. We want to find the probability that the mean number of hours they watch television is greater than 25 hours. What is this equal to? We need to find. So 27 is here, so your 25 should be somewhere here. We need to find the number of hours they watch television more than that. So we are looking for the probability, and we know that the probability is always equal to the area under the curve. It's more than 25, so it will be from 25 up to infinity. So we are looking for this area. We want to calculate this area. What we already know is if you want to find the probability or area under the curve, we use the normal distribution, okay, normal probability distribution in our calculator, which can be written as normal CDF. If you still remember from your previous chapter, normal CDF, your lower end for the area is 25. From 25 you go up to infinity, which is E99. That's how we write in our calculator. Mean is 27 and standard deviation is 0.8. You can type this in your calculator and get the result. Let's do that. Okay, here is my calculator. We do second vars number 2. Lower label for your area is 25. Upper label is infinity, which is E99. If you do second and comma, you'll get E99. Mean is 27. Standard deviation is 0.8. Then you hit the paste. So everything is pasted on the main screen. Hit enter and you get 0.9938. So 0.9938. So that is the probability that the average number of hours that they watch television is more than 25 hours. Okay, that is the example on the sampling distribution of mean. Now let's explore sampling distribution for proportion. Okay, sampling distribution of proportion, which is denoted by p hat. Sampling distribution of sample proportion is a distribution computed from all possible random samples of a specific size taken from the population. For example, you have your population here, okay, and you know certain statistic called proportion, like proportion of the students in college who take statistics. So maybe that's P. Now what we are doing is, from here we are taking a random sample of size n. We are taking all possible random samples of size n. And in each of these, okay, in all these, we are calculating the proportion, p hat. So the proportion for the sample is p hat. Proportion for the population is p. If p is the proportion of a student taking a statistic in US, then p hat is the number of students taking a statistic in these little samples that we have. Okay, random samples that we have. Now, if we form the distribution, if we look at the distribution of all these, then we say that it is called the sampling distribution of proportion. So, sample proportion, p hat is equal to p. Sample proportion, let's see, sample proportion we just write p hat. Okay, sample proportion we write p hat, and p hat is equal to x divided by n. X is the number, for example, in this sample, number of students who take statistics, divided by n is the sample size, or divided by the total. Whereas this p is the population proportion. Okay, x is again the number. Like in this one, if p is the proportion of a student taking statistics, then p is equal to x, that is the actual number of a student taking statistics, divided by n is the total number of population. We can also find the mean and the standard deviation, or we also call it standard error, for the sampling distribution of proportion. That is, mean is always equal to mean of the distribution of proportion is equal to the proportion in the population. And then the standard deviation or standard error is equal to square root of pq divided by n, where q is 1 minus p. Okay, now let's look at the characteristics of sampling proportion. There are two important characteristics that you must know. If the sample size n is large and p is not close to 0 or 1, so p is not close to 0 and 1, p is not like 0.0001, or p is not something like 0.99999, then the sampling distribution of proportion is approximately normal. So this part is clear, like p is not close to 0 or 1. But when we say n is large, how large should be n? In order to determine that, we have a second condition. Generally what we need is n times p must be greater than or equal to 10, and n times q, or 1 minus p, must be greater than or equal to 10. Okay, if n times p is greater than or equal to 10 and n times 1 minus p is greater than or equal to 10, then we say that the sampling distribution is approximately normal. So once we know the condition for the sampling distribution to be normal, and also we know the formulas for the mean and the standard deviation of the sampling distribution of proportion, we can now solve a problem involving the sampling distribution of proportion. Let's take an example. Okay, here is the example. Suppose 57% of all adults in US between 35 to 40 years of age exercises at least 4 days per week. If we take a random sample of 90 adults between 35 to 40 years, what is the probability that more than 45% of them exercise at least 4 times? Okay, exercises at least 4 times a week. Okay, let's try to solve this. So 57% of all adults, so that is your P, that's for the population, all adults, 57% or 0.57. Okay, and from here we are taking a sample of size n equal to 90. That's given to you. Now what we want to check is, we want to check whether the sampling distribution is normal or not. So for that, we need to find n times p and n times q. N times p, n is 90, p is 0.57. If I multiply this is equal to 51.3, which is greater than 10. Also, n times q, n is 90. Your p is 57% or 0.57. So q is equal to 1 minus p, 1 minus 0.57 is equal to 0.43. So 0.43 is your q. So if you multiply this, it is equal to 38.7, which is also greater than 10. That means the sampling distribution is normal. Okay, meaning of this is, okay, let me write that. Sampling distribution is normal. Sampling distribution is normal. So if the sampling distribution is normal, we can make a normal distribution for population proportion p hat. But we need to know the mean and the standard deviation of p hat. So let's find that. But what we know is mean of p hat is equal to p, which is 0.57. And then the standard deviation of p hat is equal to square root of pq over n. Square root of your p is 0.57, q is 0.43, divided by n is the sample size 90. Okay, let's type this in our calculator to find the value. So we are looking for the square root, so second, and this one is square root. I need a fraction, so I'm going to do alpha y, enter. In the numerator I have 0.57 times 0.43, and in the denominator it's 90. If we hit enter, it's 0.522, 0.522, 0.522. That is the standard deviation. So since the sampling distribution is normal, we can draw the normal curve with mean in the middle, which is 0.57. We want to find the probability that more than 45% of them exercises at least 4 times a week. So 45% or 0.45 should be somewhere here, 0.45. We want to find the probability that they exercise more than 45% of the time. That is from 0.45 all the way to infinity. So that will be equivalent to this area. Area under the normal curve from 0.45 up to infinity. So we already know how to find that probability that p hat, okay, is greater than 0.45. is equal to, we use calculator, so it is normal CDF. Okay, normal CDF, your lower end of the area is 0.45, upper end for the area is infinity or E99, mean is 0.57, standard deviation is 0.522. Okay, I think it should be 0.0. Let's check it. Yes, 0.0522. So 0.0522. Okay, let's type this in our calculator. So if we go here, you do second, then vars, number 2, lower end for the area 0.45, upper end for the area is infinity E99, your mean is 0.57, standard deviation is 0.0522. Then paste this to the main screen and hit enter, and you get 0.9892. So that is the probability, 0.9892. That is the probability that more than 45% of them exercises at least 4 times a week. Okay, that is the end of this short video on sampling distribution, where we explore sampling distribution of mean and sampling distribution of proportion. Thank you for watching.